Hi and welcome. This time around I have an interesting project. It's a project for a customer, and so I can't show you drawings, but I will be making 30 of one type of part and 30 of another type part. They're pretty simple, and so the interesting part will be how can I make the manufacturing process more efficient, because for every minute you add to a part, you're adding 30 minutes to that half the project, and it adds up quickly. So it's going to be fun trying to see how efficient I can get. I use the 3-jaw chuck because it holds the stock a little more snugly than the Jacobs rubber collet chuck, spindle nose chuck that I've got, which is over here. I was going to use it originally, but I was worried because in the past I've had a little bit of wobbling around. Even though the metal supports the part directly, I think the fins move a little if there's enough weight on the back. So that's a problem. Maybe if you support the back of the stock, which I did do over here with my lathe spider I made a long time ago. And I dialed this in. I don't normally get that careful, but this time I did, although this stock is not very long, so it's not going to be supported for very long. And then I am going to be relying on the 3-jaw chuck. So let's just move ahead and see how efficient we can make this process, and see if we can have some fun with some manufacturing approaches to things. I'm sure plenty of you will have a lot of good suggestions for me out there. I look forward to hearing them. First observation, the nominal outside diameter is supposed to be 1.25 inches, although he gives me a range 1.245 to 1.25. The rough stock is about 1.248, which is interesting. Fortunately, this part's just going to be welded in. It's not an ultra critical part. Gives a fair amount of slot, but 1.248. So I don't need to do anything, but I will remove this paint. Originally I was going to take a skim cut, but I'll just use some emery cloth, clean this guy up as I go, and or some Scotch-Brite, and we will proceed. Step 1, clean the paint off with Scotch-Brite. And by the way, I found that if you add a little of your lube on the Scotch-Brite pad, it stops it from loading up, and it lasts a lot longer. Just a little trick. Next step, facing the part and setting my 0. And by 0 I mean my Z0 in this direction here. Step 2. These are 100,000 bites. After I measure it, I'm going to take off the remaining 0.496, 1,000th. We nailed it with the file so I can get a slightly better finish, and I can also take the burrs off this. The depth is supposed to be 1/4. Looks like depth-wise, I'm just a tad over unless I have a burr here. Looks like 2,000ths over, which actually is within spec. Next step is to part this guy off, and we're going to get it to final dimensions after. So what I'm going to do, we're looking for 1.25, so we're going to go just a tiny bit past 1.25, like right there, and we're going to part this guy off. Then later on for a second operation, we'll come back and we'll make all these parts to length. And one down. Now we just need to do 29 more. All right, I'll bring you back if I find another shortcut. A couple things I've learned in the process so far. This is no longer supported, so this jaw needs to be snugged, but you don't just snug one of the scrolls, the scroll gears. Not sure what you call these. These are the gears that interface with the scroll that moves all the jaws simultaneously. So you don't just snug on one. You snug one, you spin it, you snug the next one, you spin it, you snug the next one, going all the way around. That way you'll keep each equal pressure on every jaw. I found that has helped me getting pretty accurate results. Another lesson learned. I have my 0 set on my XDRO, but then I noticed my cuts weren't smooth and I noticed my tool height was off. So I reset my tool height. Guess what? My X0 is no longer 0. I'm off by like 8 thousandths or 9 thousandths here. So if you change your tool height, you got to find your 0 again. Now I got to remove this nib and start over. Another hint, my carriage lock is here, my cross slide is here. I put the handle vertically because I kept bumping it, but important, I set the lock because I had bumped, that's the set screw to lock the cross slide. I had bumped it a couple times and screwed up my depth adjust, which is easy enough to fix, but still, another gotcha. Alrighty, next step is to get these parts down to final dimension. They're too big in this dimension still. I left them 50 thousandths oversized because I was parting them off and I was leaving a nib in the middle. So I'm going to drill out the center of this 1/2 inch. This is 0.495. I am going to relieve another section for the outside diameter that's very closely. I have to chamfer the inside edge for the 1/2 inch because the tool left radius in here. And then we're going to bring one down in size until we get to the exact right size. I'll have my measurement and I'll be able to take them in and out and repeat as necessary. So that is my goal here. And we got plus or minus 5 thousandths to work with, so that's pretty light tolerances, easy to work with. So let's drill some holes and I'll be right back. So I'm shooting for a flat bottomed hole. So I'm using an end mill that's center cutting. And once I just touch, there we go. I'm going to set my 0. Using a carbide cutter. Okay, after boring the 0.5 inch hole, I followed with a 5/8 end mill just to open it up so that I can get this 1/2 inch boring bar in there. This is the one from Solid Rock Machine Shop, an excellent boring bar. Check out their site. It's two-sided, so if you break one of the sides, you got another side to continue with. Won't have to stop down work for the day. Well-made, tool steel, fantastic. Solid Rock Machine Shop. Check out their YouTube channel as well. I'm going to take this over and blow it out, but here's our fit. Yeah, there we go. That is a really good fit. There we are. Wow. Talk about a real good fit. So the 1/8 inch pin that keeps these spaced apart is still in there, and we need to remove that. I might want to take at least another 1,000th off so that it's easier to get the parts in and out. So I tightened the part in place, made sure it's seated all the way, and then when I got it tightened, I made a mark here so that I can come back to it every time. The line on the tightening chuck with the line in the split on the cast, not the casting, but on the base here. So because the 5C collets go in and out as they're tightened, that'll help control depth. Wouldn't want it to vary too much, not that this is a critical measurement. So we're going to take a pass off this. We're going to take 40 thousandths off, see if that is enough, and if it is, then we'll stop there. We'll make that my 0. If it is too little or too much, this is a test piece. Actually, let's do 35 so we can see where we're at. We can go faster than this. I found out that the cold rolled cuts better at higher RPM. Okay, I got within 0.003. Set my new 0 here. So there's two parts to this. There is this bit, and I don't know if the tools will line up right, but if they do, we're going to come back and give it a chamfer. Remember how I said this position's important? I went around one more full revolution, made 0.010 difference in the thickness, the final thickness. Good to know. So I discovered that taking the parts in and out has taken longer than I thought. So to speed up the operation, I am going to reset my 0 each time, and then I'm going to come over to the exact same spot to do the chamfer, which is 2.25 on the X and 0.840 on the Z. And so I just have to reset back to my 0 on my Z for the next cut and load the part. We'll see which takes longer, but I think taking the parts in and out, especially making sure there are no chips underneath, is taking longer. So that's what we're going to do. One way to improve consistency is to count the revolutions in and out. Tightening this guy, 1, 2, 3, 4, 5. I'm doing 5 revolutions each time, and that's helped me get within 0.004, 0.034. Still not great, not very pleased with it at all. Got to be a better solution besides the collet closer. Maybe I'm doing something wrong, haven't quite figured it out yet. Well, I discovered something interesting. I think I know what part of my problem was, at least. The last 12 or so, only one of them was out of plus or minus 0.002, or no, just plus or minus 0.001 variation. One of them was off by 0.004, but the rest were plus or minus 1. I think I found the problem. So they made this soft so it's easily machinable. Unfortunately, they made the taper soft too, and I noticed here that my collet chuck, which is hardened, was actually scooping some material out on the back, which is really ridiculous. I don't think that's supposed to happen. Maybe that's my bad. I did have some problems with some parts popping loose a little bit. If I had been super careful with diameter on all of these, I could have made the inside diameter and the outside diameter precise. They were close, and this was only a couple thousandths over, but with my plus or minus 0.005 tolerance for most of the dimensions on this part, I didn't hold to that tight a tolerance, which means I couldn't make this that tight because some wouldn't fit. As a result, it was only grabbing on the large section, which if I pushed too hard and did it in one pass, the 0.050 in one pass, that was too much. So I had to break it up into 2 passes, which I did for all the subsequent passes, and that's when I started improving a little bit. Counting the tightness revolutions was key. Making sure there was no debris in here was key. And even with all that, plus or minus 0.001 was as good as I could get. So anyways, lesson learned. Let's go take a look at the parts. Here are the finished parts. And the back of each one has a chamfer. And I made the chamfers all match. I needed 30, I have 32. I made extra parts to screw up on a couple when I was setting up my fixtures. I didn't end up needing it on this one, but it's very possible that you need that. In other projects, I've definitely needed it, so I recommend making a couple spares just to help set up your fixtures. All right, on to the next part.